Here we're being asked to solve for x, and we have x both as an argument for a cosine as well as a power here for the 4. So when faced with a situation like that, what you want to do is to separate the two instances of x. So you want to separate the 4 to the power x from the cosine. And you can see that the cosine is repeated twice. There's a cosine here and a cosine here. So if we take cosine as a common factor, we can factorize the expression into something that looks like this. Now, it's always good to factorize expressions because when you have a product of two expressions that's equal to 0, then you can say that each of those expressions, or either of those expressions, needs to be equal to 0 for the product to be equal to 0. So either cosine x equals 0, or 4 to the power x minus the square root of 2 equals to 0. And that's good news because we can solve each of these. We can find x, we can say x1 is the inverse cosine of 0. And the inverse cosine of 0 is 90 degrees. And that is within the range specified. So that's an acceptable answer. And we can find the second solution. We can say x2 is 360 minus the first solution, which is 270 degrees. And that's also within the specified range. So that's an acceptable solution. Now, if we go back to our second expression here, then that looks rather difficult to answer, but actually it's not that hard. If you remember that 4 is simply 2 to the power 2, you can write that as 2 to the power 2 to the power x equals square root of 2. And you're allowed to change the order of these powers, or you could simply write it as 2 to the power 2x equals 2 to the power half. And because we have the same base, you can simply say 2 to the power 2 times x equals a half. So 2x must equal to a half, and therefore x3 would be 1 over 4. And that too is within the specified range. So we could say that the final solution, x, could be 1 over 4, or 90 degrees, or 270 degrees. And that would be your final answer.